Hi, in this video, we're going to be looking at the effect of a function's degree and its leading coefficient on the end behavior of that function. So I just mentioned a bunch of vocabulary words that you may or may not know. So let's make sure we understand what those mean before we move forward. So the first thing I mentioned was degree. And so the degree of a function is the highest exponent. That's going to tell us a lot about a graph, where it starts and where it ends. The leading coefficient of a function is the coefficient of the term with the highest exponent. So the coefficient of the term with the highest exponent. And specific to the end behavior is what the function is doing infinitely to the right and infinitely to the left in each case. Infinitely to the left, infinitely to the right. So specific to that, when we're focused on exponent or degree, and when we're focused on that leading coefficient, these are the two things that we're looking at. We're looking at if our degree is even or odd. And for the leading coefficient, we're looking at whether that is positive or negative. Okay, so now that we know that, how do we use that information to determine end behavior? We're going to get into that later in the video, but what we are going to do in this part of the video is make sure that we can, from a visual, understand how to write end behavior. So when we're looking at the end behavior of a function, again, we're looking at what happens when you go infinitely to the right and infinitely to the left. So in order to state that, you're going to say as x approaches infinity, that means going infinitely to the right. And as x approaches negative infinity, that means going infinitely to the left. So as we look at our first graph, number 1, as x goes infinitely to the right, notice that the function or the graph, which is that red line here, is also going up. So f of x is going up. And so we would write that f of x approaches infinity as well, since it's going up. So in other words, this translates to as x goes to the right infinitely, y goes up infinitely. But as x goes to the left infinitely, y is going, notice it's going down. So we would write here, f of x approaches negative infinity. All right, so that is question 1. Question 2, we can go a little bit faster. We're always going to start off with the same first piece. What happens as x goes to positive infinity and what happens as x goes to negative infinity. So looking at our second graph, as x goes to the right, notice y is going down, so our function is going down, which we write as f of x approaches negative infinity. And in this case, f of x, as x is going to the left, notice y is going up, which means that f of x approaches positive infinity. We don't have to write the positive, but we know if we don't see a sign, that means it's positive. All right, so we did the first two, and notice that the second two actually do the same thing. So these are cubic functions, so our degree in this case is 3, our degree in this case is 3, our leading coefficient is positive 2, negative 2. However, notice that the function overall, just like it went up here, it's doing the same thing here, overall going up. All right, so the end behaviors of both of these functions, number 3 and 4, are actually the same as the end behaviors of our lines. So let's get that down on the page. And that is for questions 3 and questions 4. All right. So as we move forward, now our equations have an even leading coefficient, or sorry, have an even degree. All right, so now we have an even degree for number 5 and 6. We have an even degree for number 7 and 8. All right, and so notice these graphs look a little bit different. So first we have that parabola shape for a quadratic, which opens up. Notice it starts and ends in the upward position. So when y, or f of x, is approaching positive infinity in both of these cases. But over here, it's going down on the left and down on the right, approaching negative. F of x is approaching negative infinity and positive infinity. So again, we always start with the same thing. So let's make sure we have that. What happens as x approaches positive infinity, and what happens as x approaches negative infinity. All right, so as x approaches positive infinity, f of x approaches, so for number 5, positive infinity, and f of x also approaches positive infinity. So the difference here is that when we have a quadratic, f of x is always going to approach positive infinity on the left and on the right, as long as that leading term is positive. All right, so let's keep going. Let me duplicate this and fix it. So it's not yet correct. For number 6, in that case, our f of x is going down on the left, which means it's approaching negative infinity, and down on the right, approaching negative infinity. Now, if we look at the overall graph here for our quartic, on the left and on the right, it's approaching positive infinity and positive infinity. And over here, it's doing the same thing. Overall, it's going down on both sides. So our answers here are actually going to be the same as it was for the quadratic. So that's the answers for number 7. Number 7 and number 8. All right, so we were able to do these end behaviors when we were able to see the graphs. But my argument is we don't need to see the graphs in order to determine what the end behavior of a function is. So let's notice a few trends, and then we'll try it on a graph that we cannot see. All right, so notice that, a few takeaways here. Notice that when we have an odd degree, we had an odd degree here and an odd degree here. Also, odd degree here, odd degree here. Notice that when you have an odd degree, the graph starts and ends on opposite f of x values. So it starts here low, ends high. It starts here high, ends low. Starts here low, ends high. Starts here high, and ends low. And so this is important because this helps us to differentiate between an odd degree, which is the first 4 questions are odd degree questions, and an even degree question or an even degree function where it starts and ends in the same direction, where f of x is at the top in both these cases. So it's like a mirror image over here if it's a quadratic. But generally speaking, if there's an even degree, you are going to have something that looks relatively similar to a quadratic. Now, where you're focused on the leading coefficient, notice in every single case when the leading coefficient was negative, every single case, the graph ended at negative, approaching negative in infinity. So it was going down here, down on the right here, and down on the right here. So on the right side, it always goes down, despite whether our graph is or function is has an odd degree or if it has an even degree. It always ends going down. All right, so now that we have all of that, now we can look at a couple examples where we don't actually have a visual and we can still tell what the end behavior is. So here we have a function, f of x equals negative x to the third plus 5x minus 2. All right, so now we know in this case, or degree is odd. That's going to be important. And our leading coefficient is negative. That is going to be important as well. So because our leading coefficient is negative, we know it's going to end downwards. Because our degree is odd, we know it's going to start on one side and end on the other. Start at the top or bottom and end at the other end. All right, so I want to give that visual because I don't think it's clear if I just say it. All right, so again, because the degree is odd, it's either going to go up or go down. However, because the leading coefficient is negative, it's going to go down. So we know that this is not the right answer because that is going up. So we know that overall, this is what our graph is doing. Now it is a cubic, which means it's not a straight line. So however the shape is with the turning points, it's not going to look like that. But the overall journey of our graph from left to right is it's going to start at the top left and it's going to go down to the bottom right. All right, which means that when we're looking at end behavior, in this case, as x approaches infinity, positive infinity, f of x will approach negative infinity. And as x approaches negative infinity, so on the left, f of x approaches positive infinity. So that means as x approaches positive infinity on the right, it goes down. As x approaches negative infinity on the left, f of x goes up. So again, remember this is not the shape because a cubic does have turning points, but overall this is the general trend of the graph. All right, let's try one more and hopefully that will help solidify this topic. So f of x equals, let's go with x. Let's go with 2x to the fourth minus 5x squared plus 3. All right, so in this case, we see that our degree is even. And we see that our leading coefficient is positive. All right, so the fact that our degree is even tells us that our graph generally will look similar to a quadratic. So it will look similar to this or to this. And again, remember, because it's a quartic, it's not going to look exactly like a quadratic. It will probably, or it will have turning points that a quadratic does not have. However, we do know it's going to open up or open down. Because the leading coefficient in this case is positive, it tells us that we're looking at something that opens up, that goes infinitely up to the left and up to the right, not this one. All right, so now looking at that general shape here, again, remember there will be turning points because it's a quartic and not a quadratic, but looking at our overall shape, we see that as x approaches positive infinity, f of x approaches positive infinity as well. And as x approaches negative infinity, f of x still approaches positive infinity. All right, so the big takeaway I want you to see from this is that f of x will have opposite signs here that it's approaching when there is an odd degree, but when there is an even degree, f of x will be approaching the same sign. So positive infinity in both cases, or if I had another example, it could have potentially been negative infinity, but they would have to be the same. And in this case, they would have to be different. All right, so I know this video had a lot. Hopefully it helped. If not, rewatch, and hopefully that will solidify this topic for you.